Good morning. All right. Well, we've had a few days of catching up. Hopefully you are caught up because we're going to start picking up the pace. We only have a month left. Finals are scheduled for May 20th. So we've got this whole unit to finish and then some final review. So let's go ahead. Let's get into ellipses. Ellipses, similar to our circles. They have some similarities in regards to you have your center. An ellipse is we refer to it when you're younger as an oval. And we talk about things moving in an elliptical manner. The sun and the moons have an elliptical movement, so it's not a complete circle. It has more of a stretch to it. So let's go ahead, let's look at our first example here. Or let's look at the actual formulas. And everything's formula based. We kind of saw in that first lesson that we did earlier last week, it's been forever since we've had a lesson, where I focused on how things shifted and moved and not so much the actual formula values, because all these A's, B's, they can get confusing. But let's go ahead, and if you want to have this as a reference, we'll go ahead and have that so you can have those formulas. Some people prefer to look at the formulas and strictly use that. So there's two different types of ellipses. You can either have what you call horizontal ellipse, where it's longer horizontally, or you can have a vertical ellipse where it's longer vertically. So you can see the difference. Along my vertical axis is where the stretch is here, so that's a vertical versus a horizontal ellipse, which is going to be longer along the horizontal axis. So when we talk about an ellipse, we always start off with the center, just like we had in a circle. And our center for a circle was our HK. Same thing here. My HK, remember, it's always going to be the opposite signs of what you see there. Well, for my vertices, if it's going to be a horizontal ellipse, then it's going to have vertices at H plus or minus A, K. Co-vertices are going to be at H, K plus or minus B, and I'm going to talk about all of these values. For my foci is always going to be on the major, what we call the major axis, so I'll label that, and we use our C value. C squared is equal to A squared plus B squared. So we need to figure out what is C, and that gets, you can solve for that from your A and your B value. These are your A and your B values down here. And then that point where the focus is going to be H plus or minus CK. Our directrices are going to be, if it's a horizontal, then they're going to be my X is equal to H plus or minus D. So it was D. D is going to be A squared all over C. So a bunch of formulas right there, equations. Let's look at the actual graph over here. So these right here would be our directrices. These points right here that are going to be the further away ones, the points that are further away, are what we would call our vertices. And always along that axis where the vertices are going to be our foci. They're always on that same line. And this line from here to here, this point, when we go across from our vertice to vertice, this is what we call the, excuse me, these are what we call the major axis. So vertice to vertice is along the major axis when we go vertice to vertice, and our foci are always on the major axis. Then these 2 points right here that are going to be closer together, these are what we would call our co-vertices. So I'll label those as CV throughout, co-vertices. And the co-vertices are on the minor axis. So the minor axis is always going to be smaller than the major axis. It's going to be closer together than our axis that's further apart there. When we talk about this information for my foci, the foci, my foci is going to be the sum that is constant And what I mean by a sum that is constant, so from my foci to foci, so if I have some point here on my ellipse, then the distance from my foci to that point to my other foci, so say this is some D1, this is some D2, the distance, the sum of D1 to D2 is always going to be the same as if I pick another point over here and I do this sum and I say that this is some D3 to my, I'm going to add my D4, they always have to be equal. The sum of the 2 points, the sum of the lines to any point on the circle has to be equal. In other words, again, this D1 plus D2, the sum of these two has to equal the sum of these two. If that's true for any point, and that's from your foci to your other foci. Let's see, did I miss any of the labeling there? Okay, so what's the difference between these two? How do I know if it's horizontal or major? So when we talk about our a squared and our b squared, if it's larger, the a is larger than the b, then that's going to be the axis that it's along. So in this case, for a horizontal, a is greater than b. My a is under my x, the greater value, my a is under my x value, so it means that it's going to be longer along my x axis. So it's going to be longer along that x axis. So when we talk about it here, this a value is under my y now, so it's always going to be longer along my y axis then, Notice that this is my center, this distance to my vertices is my a value. From my center to my co-vertices is going to be that b value. It's always the case, So let me go ahead and write the equations to go with our vertical ellipse. So my center is still going to be my HK. Oh, let me put mine. I didn't open up the chat in case you guys have questions. There we go. So my center is HK. My vertices are going to be at HK plus or minus my A value. My co-vertices are going to be at H plus or minus BK. My foci, remember my foci, to get that C value is going to be C squared is equal to A squared. You know what? I wrote plus up here. It's a minus. Fix this. Major fix. A squared minus B squared. A squared minus B squared. You're going to find your foci for your hyperbolas coming up too. So it's always when we talk about that C value, if this is positive, then these are going to be minus. So if this is hyperbolas is going to be a minus and this is going to be a plus. So just to kind of point that out. This is going to be minus. So that's my fault. So sorry. Fix it, fix it, fix it. Okay. And then that point is going to be at H. It's going to be K plus or minus C. And then my directrices. So in this case, since it's going to be a vertical ellipse, then this is going to be a y equals, and it's K plus or minus my D. Remember, we said that D is equal to A squared all over C. So again, that's that C value there. When we talk about C, we're talking about that value for our foci. So how does all this stuff work? What does it look like? Bunch of equations. Let's work some of the problems through some, because I think that's where it really kind of puts things together. All right, so here's what I have. I have an ellipse that has vertices at 0, -5, 0, co-vertices at 0, 2, and 0, -2. So I'm going to just quickly sketch a little graph because I think visuals are very important. It helps us figure out what's going on. Okay, so my vertices 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. So -2. This is 5, 2, -5. Okay, so here's what I have. I have here at 0, 5, I have a vertice. I have a vertice, I have a co-vertice, and a co-vertice. So my ellipse is going to look something like this. All right, so my question then is, first one, it says, on which line will the foci be graphed? So use the information to answer these questions. Well, remember, my foci is always going to be on the major axis, and the major axis goes from vertice to vertice. So this is my major axis, so my foci have to be on this axis, which is going to be, or on this line, and in this case, that is just my y is equal to 0 line. So then my next question is, well, where are the foci at? How do I figure out those foci? I want to know, where exactly are they at? Well, here's some information that I know from graphing this. I know that my center has to be in the middle of the 2 points, right? That it has to be in the middle of the vertices, has to be in the middle of the co-vertices. Here's where my center is. So my center for this ellipse is at 0, 0. Okay. If I know where my center is and I know my vertex is, this distance from my center to my vertice is my A value. And in this case, A is equal to 5, the distance of 5 away. The distance from my center to my co-vertice is my B value. And in this case, it's a value of 2. So I know my A and my B value because I know the distance from my center to my vertice, distance from my center to my co-vertice. Since I know A and B, I could figure out what my foci are going to be. I need to solve for C though. So I know that C squared is equal to A squared minus B squared. Well, A I said is 5, so it's 5 squared minus B squared is 2. So I have 25 minus 4 is going to be 21. So C squared is 21. If I take the square root of 21, I get C is approximately 4.58. So when I'm graphing, it's kind of nice to put in that decimal form because it's easy to count that 4.5-ish, almost a little over 4.5 away. So that C value, this is talking about the C, not the center. This is the center of the ellipse. That's not the same C. That's just because I didn't have enough space to write out center. So if I want to know where the foci are, same idea as what we did for our A value. We count from the center, that A value, to find the vertices, center, that B value to find my co-vertices. To find the foci, we count the C distance from my center. So I would count from my center along my major axis, so left and right, I would count 4.58. So a little more than 4.5. So 1, 2, 3, 4.5, so it'd be somewhere right there, and I would count 1, 2, 3, 4.5, somewhere right there. That's exactly where the foci are going to be on the graph. So I went this direction. I went negative 4.58, right, from my center, and I went a positive 4.58. That's going to be my X value, right? My Y value is just 0. So those points are going to be here, and this is going to be here. So my foci are going to be at negative 4.58 and 0, and a positive 4.58 and 0. It's like a drop down bar for these problems, so it's either going to be written as a radical or as a decimal. It's going to be one or the other. My next question says, what type of lines will the directrices be? Well, if we have a ellipse that's going to be going horizontally, it's going to go horizontally, this is going to be horizontally, then the directrices have to go vertically, because remember, directrices are going to go, they're the same distance from my vertice to that foci as it is the other direction. So they're going to go somewhere in here and somewhere in here. So they're both going to go up and down or vertically. Going to go up and down or vertically. So in this case, they're going to both be vertical. And then it says, well, where are those directrices at? Well, remember our equation. If it's going to be a horizontal ellipse, then we're going to use our x is equal to h plus or minus d. So we're going to use x is equal to h plus or minus d. Well, what is that H? Remember, H comes from our center. HK in this case, it's just a 0. So this is just the value of 0. I don't even need that there. It's just going to be H is going to equal plus or minus D. If that's 0, if this is 0, I don't even need it. But I do need to figure out what that D is. So we said from above that D is equal to A squared all over C. I already know my A squared is 25. A was 5. So 5 squared is 25. My C we said was 4.58 or the square root of 21. So whatever one you want to use. And I put that into my calculator and I get 5.46. So it's going to be from here from my center, 5.46 to the left, and from my center, 5.46 to the right. So my answer is going to be X is equal plus or minus 5.46. Done. Kind of a lot. So first one is probably a little bit overwhelming, but it's the same patterns each time, same ideas as what we were working with the other day. So let's go ahead, let's have a couple more. So hopefully you get a little bit more comfortable with it. And again, this is just the instruction. We have assignment tomorrow that I'm going to work on, and then we have our quiz the following day. So let's look at some of the other type of problems I'll come across. So complete the statement. So I know that this is going to be a vertical ellipse. It says that the major axis has endpoints at. Where are the major axis endpoints? Well, remember, my major axis endpoints are going to be on my vertices. These are my vertices, and those are points C and D. So they're going to have you just pick the points C and D. Blank is the focus of the ellipse. So what's a focus? So here's a focus here at F and at E. So it's a drop down, so you pick either one, whatever they have. The center of the ellipse is located. Well, the center is going to be directly in the middle of my vertices, directly in the middle of my co-vertices. So this would be my center here. And in this case, that center is at the origin. So it's 0, 0. The vertices of the ellipse are located at. Those vertices are at the endpoints of your major axis. They're the same. So that's also going to be C and D. The directrices of the ellipse are lines that are, they're going to be perpendicular. And it is multiple choice, so the wording would have been there for you, or a drop down menu. So it's perpendicular to the major axis. So remember, if this is my major axis, these are my vertices, then my directrices are going to go this direction. It's going to be perpendicular to the major axis. So these would be my directrices going horizontally. So if it's a vertical ellipse, then the directrices are going to be the opposite. They're going to be perpendicular to it. Questions, questions. All right. Now we're starting to work with numbers. This is great. Let's put it actually together with all these variables. Okay, so we want to figure out what is H, K, A, and B. So what I need to do is I need to figure out, well, where's the middle? So sometimes I look at this and I'm like, okay, well, I'm not quite sure where this is. I'm going to kind of just, there looks like my lines and middle's there. So I kind of just sketching to see like, okay, where are they intersecting horizontally and vertically on that same difference? And so it looks like it's going to be right there. My center is going to be at 3, 2. And if that's the case, then when I go up 1, 2, 3, 4, I should be going down 1, 2, 3, 4 so that it is directly in the middle of the 2. So that's going to be a distance of 4 here. Here I'm going 1, 2, 3, 4, 5, and it was 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So okay, I'm directly again in the middle. I need this to be in the middle of the 2. So is this going to be a horizontal or a vertical ellipse? Well, how do I know? Whatever one is larger. So in this case, this 5 is larger, which means that it's going to be, my type of ellipse is going to be along that axis. So it's a horizontal ellipse. That means that that A value is always the bigger one. So in this case, A is going to be 5, B is going to be 4. This centerpiece is my H and my K. So I have actually everything I need to write an equation for this. So my HK was 3, 2, my A was 5, and my B was 4. So if I want to write this ellipse as an equation, it would have been x minus 3 squared plus my y minus 2 squared all over A squared and my B squared, and it's equal to 1. In other words, I would have x minus 3 squared all over 25 plus y minus 2 squared all over my 16 is equal to 1. And if they asked you what is the equation of this ellipse, it's just right there. So from identifying just that A, B, and the center, I have my equation. And my very last one. What other types of problems are you going to see? So again, this one, you need to come up with an equation for an ellipse, and they gave you different pieces. So I like to go ahead and I like to see what does it look like. When I had done these notes, so I don't know if it's still like that. This was an error here. It was a typo. It should have been x is equal to 33.8. I don't know if they've already fixed it or not, because it's been a couple weeks since I went through this. So it could still be an error on your end, or it might not be, but just watch out for that. Okay, so what do I have and how do I come up with my equation? So we know in order to come up with the equation, we need to know H, K, A, and B. Well, I have a center here at 3, 1. Check, there's my H and my K. Awesome. So what is that going to look like? So let's kind of draw a little sketch here. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8, 1, 2. I just draw kind of what I know I'm going to need for the graph. It doesn't need to be something elaborate or anything like that. So I know at 3, 1, so at 3, 1, there's my center. I know my H and my K value. Okay, so what else do I know? I know my focus is at 8, 1. So my focus is here at 8, 1. Okay, so if my focus is at 8, 1, then that means that my major axis has to be going this direction, right? Because my focus has to be on the same line as my major axis. It has to be on the same line. So my focus and my center have to be on my major axis, which means if my focus and my center are on my major axis, it means I'm going to have a horizontal, excuse me, a horizontal ellipse. Okay, so center to my focus, that distance, remember that distance is always going to be my value of C. So in this case, C is equal to 5. Because if I'm here at 3, there's 4, 5, 6, 7, 8. There's a distance of 5. So my vertice, a vertice has to be somewhere over here. I don't know where it's at, but I know it's going to be along that same major axis. So the other piece that I know is that my directrix is at 33.8. Again, this is a misprint. It should be 33.8. So I'm going to go over here, and I know it's an x equals, and I'm going to say this is my 33.8, and this is my directrix, okay? I know that the distance from here to here is my D value, right? It's my D value there. Okay, so how do I figure out this information? Knowing this, I still don't have my A and my B. How do I figure out what A and B are? So what do I know? I know that C squared is equal to A squared minus B squared. Okay, don't know A or B, not very helpful. I know that D, this D, is equal to A squared all over C. Well, I know what D is, and I know what C is, right? So can I use that to solve for A? Yeah. So this was a little bit tricky because I don't know A and B. I do know my C and I do know my D values. So those are things that I can use to help me figure it out. So here's what I know then. D is equal to A squared over my C. D is going to be 33.8, which is equal to, I don't know my A squared, but I know my C is 5. Distance from my center to my foci is always my C value. Multiply both sides by 5, so I can solve for my A squared. And I end up with A squared is equal to 169. Now I can find my A, but remember, not necessary because my equation is over A squared. So if I solve for A, then I'm just gonna have to square it again. So I could just leave that as A squared. Now that I know A squared, I know A squared, I know my C, I can solve for B. So I'm gonna use that information to help me solve for my last little piece of the puzzle. I know that C squared is equal to A squared minus B squared. C squared is going to be 25 is equal to my A squared is 169 minus my B squared. I'm going to go ahead and add B but to both sides and subtract 25 from both sides, and I get B squared is equal to 144. So which equation is it going to be? Well, remember, it's always going to be, if it's a horizontal ellipse, it's going to be my x minus my h squared all over my a squared plus y minus k squared all over my b squared is equal to 1. HK, so it's going to be x minus 3 squared, and this is going to be y minus 1 squared. So we already could eliminate those two, right? My A, we said, was 169, so my A squared, sorry, is 169. My B squared is 144 is equal to 1. So it's going to end up being this very first one. And we're done. So a lot to take in. Tomorrow, again, we'll do more examples. We'll work through them. We'll either figure out what's the equation going to look like, or taking the equation, graphing it, and finding out where's the focus going to be, the directrix, and so on. If you guys have any questions, please reach out to me. But remember, this week, they're all going to be 9:30 meetings. I had other stuff going on that I had to adjust, so it was just too much to kind of change it. Like one day, this, that, it was just too chaotic. So I just made it 9:30 for the week. And I will see you guys hopefully tomorrow. You guys take care. Welcome. Bye. Bye, dear.